All right, so this is technically speaking the data visualization, but because I ran a bit long yesterday, I'm going to finish up Intro to Pandas. So people who weren't expecting that, sorry, but I am going to finish it off for the people who were here for Intro to Python yesterday, and then we'll slide right into data visualization. The other thing is reminders, like if you are not expecting that, the Docker, the Docker containerization is in the other room. This is the other lecture today. All right, just making sure that I will be trying to, I don't have like a helper today, so I'm going to be trying to monitor the Slack chat through my phone. So if I don't respond to you quickly, that's because I have it propped up on here on my desk. Fingers crossed this works out. But if you have questions, obviously, you can also just unmute yourself on the Zoom and I can try to address it there. All right, let's get started. Hopefully everyone still has their Jupyter Hub opened up and you're able to make new notebooks. Let's get started by starting a new Python notebook for our Intro to Pandas. I'm going to rename this very quickly. Rename Intro Pandas. All right, for those of you who were with me yesterday and those of you who are not, I'm Kelly Chang. I'm a postdoctoral research scientist with Ariel Rokem. Also something to note is that we posted that there will be review sessions on Friday. Sort of the review sessions are anything you want to cover in that we've covered through lecture during the course of this first week, but also additional information that you would wish to know about. So I don't just teach Intro to Python things. I also do research. I have done research in my graduate studies in like fMRI, diffusion imaging, as well as quantitative imaging as well. I'm also an MRI technician. So if there's questions about these kind of things, I also can answer them during our review sessions. So feel free to go to those channels, post your messages. We'll sort of freely wander around and try to address those. And again, reminder, those are on Friday. All right, so Intro to Pandas. Hopefully I can get through this relatively quickly. Hopefully we all are able to get a Python notebook as well. Let's get started by importing our Pandas library. Import Pandas as PD. And real quick check, is this font size good for everyone or should I make it a little bit larger? Okay, thumbs up, excellent. I'm going to make it larger for myself because I am myopic. And so just running this with the control enter, import pandas as PD. PD is just your standard abbreviation for pandas. So if you see these kind of very standard or stereotyped abbreviations, that's because for the most part, people who wrote the package like it that way. Yesterday, when I was in the Intro to Python section, we talked a bit about dictionaries. And so you can already imagine that a dictionary will translate into a data frame or a pandas data frame very easily. People mentioned yesterday as well that they're very familiar with R. This is very similar to our data frames in R if you are familiar with those as well. But let's see how it looks in Python. So if I start off with a dictionary, my dic, with those curly braces, let me just have a column called A. I'm going to have it have a list of 1, 2, 3, 4. Close my square braces. A column B with other numbers, again, just sort of randomly making data here. Maybe another column called C, and then now maybe do 10s, 11, 12, 13. If I run this and have it print out on the last line here, we have a dictionary, right? Again, like I mentioned yesterday, and also for people who just as review, this is just a dictionary class where you can refer to each of their values by their key field. In our case, the key fields are A, B, and C. And the really simple way to turn dictionaries into Panda data frames is actually to have, get a new variable here, my df, short for data frame. You'll also see that fairly commonly. I sort of ascribe by that as well. It's just called panda pd.data frame. It'll assign this dictionary the pandas data frame class. Just give it the variable, my dictionary, have let me print out my df. Please sort of take a look at how the dictionary is currently being printed out, right? Horizontal wise has the curly braces and everything we just typed out, but now just in one liner. When we actually assign this to be a data frame, one of the first behaviors that changes is that we actually have it print out that something looks a little bit more sensible, a little bit more data frame-like, and a bit nicer to look at. And you can immediately see some properties about this that are nice. You see that the headers or the field names that were originally are now bold. These are now our data frame table headers. And we also have automatically provided for us, unless we specify it otherwise, a row index. So, right, this is row 0 or the first row because Python is zero-based indexing. And this, hopefully, again, if you guys come from the land of R, this or even MATLAB structures somewhat, these should maybe things that are very familiar to you. Okay, any questions so far? Just making sure that's a quick review. Excellent. Scroll down. So that's how you could manually type out a dictionary and create it into a data frame. And then you can use all of the Panda associated suites and things like that. Another thing that you can do is just read a CSV. Oftentimes when we share data amongst many different sites, different collaborators, we have them as, I don't know, CSVs, so comma separated values, TSVs, text files, other delimited file types. You can also just read those in with Panda pd.read CSV, read_CSV. You can also, much like R, you can read these off of URLs or anywhere off of the internet. So we can do that, but just for simplicity, hopefully it works. I'm going to open up the file browser here. In curriculum, under Chang visualization, there's actually, oh, should I actually go over to intro Python data? There are a few CSVs I automatically downloaded in case our internets were crashing. So these are here, and let's try to read them in. I'm currently in home, Jove, Yan, and I think it's, I said curriculum, /Chang intro Python. Someone catch my typos. Subjects, cs.csv. Aha, I can catch my own typos. Fingers crossed that actually works. Excellent. Close that file browser up. That was me just getting the padding, but I like to see most of my code online. The first argument in was basically either local paths to that file. Again, like I mentioned, it could have been a HTML URL somewhere online, like GitHub or something like that. You can also download it from there. And what this particular CSV contains is actually some information. You can sort of very faintly see it. Row index numbers, subject IDs, age, gender, handedness, and IQ scores for a variety of people that were measured. I'm going to clean this up a little bit with a few more arguments. There is the use calls, basically which columns to read. Don't read the whole entire table. It could be much bigger than this. I'm just going to grab the first 1, 2, 3, 4, 5, 6, 7 columns. We can give it a quick run to take a look. Okay, cleaning some stuff up here. If there are NAS, we can also automatically assign them to have a certain value. NA values equals not a number, NANs. Run those. You can start to see that these are getting populated with NAS. And then also, if I do or do not want that index column, or I want a particular column in my data frame to be the index, I'm going to assign it to be the first one. And you can see that actually turned that subject ID column. It sort of, if you sort of notice, there's actually a difference in height of where these column headers are. That doesn't actually matter in Panda data frames. What actually happened is that the subject ID now became like a row indexer, as opposed to just having the row index by position be their named values. And the rest of the columns, age, gender, handedness, etc., those are still referable by their column headers. Okay.
Kelly, do you mind a quick question?
Of course, please.
I mean, again, I'm not sure that you necessarily have the answer, but again, why is Python indexing starting at 0 compared to anything else really that starts at 1?
Oh,
Why is that?
Honestly, historically speaking, I don't really know. There is some other coding there are actually quite a few number of coding languages that start with 0. I believe it actually mathematically works out a little bit better. I don't know, but most people learn like MATLAB or R these days from the get-go, and I know they're 1 base index. It's just something to remember. If like I have a bug, especially when I was first learning Python, that was like the first thing I remember I messed up on.
Yeah. But also
just
it gets kind of complicated with tables because then you always need to factor indexing in when you're selecting columns, for instance, and that can be kind of tricky.
Yeah, so I do actually advocate for having some sort of meaningful index column. So now that I've made my subject column, for example, to be the index, I don't have to refer to it by row number, let's say. I can refer to them by name. It becomes a bit simpler that way.
And is that, again, inclusive of the last one or not? Is that like selecting a number of columns, or would 7 be included in this case or not?
We'll get to there. Thank you reading my mind. All right, so I was messing around reading this, but if you've also noticed, I wasn't actually assigning it to be any sort of variables. I'm just going to call it df subjects for now. To make sure, okay, that suppresses the print. df subjects, a very useful, especially if your CSV or your data tables are really long, dot head, just to show you the first, I believe, 5 or 6 rows. 1, 2, 3, 4, 5. First 5 rows. Other really useful methods that are part of the Python suite. Getting a new cell down here. df subjects info with parentheses. Also will give you a really quick peek into your data frame. As well, it'll show you what kind of columns you have, the number of values that aren't NAS in here, and as well as the data type. So you can do a quick cursory look over. So if something's supposed to be a string and it's not, or something's supposed to be a numeric and it's not, you can really quickly assess it from here. You also sort of see that gender and handedness, they say object, and that's because it's a string. A string is technically an object in Python. All right. Other really good functions just to know off the top of your head, df subjects. Once again, if I can spell, describe. This will give you a really quick, your 5-number summary, your mean, your standard deviation, as well as your count. So like the usual things that you would like to know, especially about your numerics. And you can see them very quickly for all the columns that it's able to calculate. And for this describe function, it's going to work on anything that's numeric immediately and ignore all the string objects and then do that for you. Again, if you guys know R, it's basically like summary. It's like data frame summary. And so this is the equivalence here. All right. So just as sorry, I didn't catch your name because I have my Zoom closed just so I can see my screen, but person on Zoom asking how do we reference or index into data frame columns this way? Opening up another cell down here. Well, we can do it actually, Python allows you a lot of different options. Pick and choose your poison. You know, you can go back and forth, but there's many ways to index into your data frames. The one thing you can't really do is df subjects. If I just try to index the first whatever, it's just going to yell at me. It doesn't know, right? Because we have both rows and columns, but sometimes people maybe want to do this, like right first row of something, you still can't do it. And you're like, okay, gosh, why is my data frame yelling at me, even though it's supposed to be a matrix-like thing? And that's because, comment this out just to know that you guys, it's an error, is that it actually wants you to use pandas like localizing methods. So df subjects dot loc for location. And loc is for named index and indices. So if we scroll up a little bit, and I remember, right, the subject column is now my indexer. I'm actually just going to grab the first subject, let's say subject underscore 001, copy and paste that as a string into here, and I run, I'm able to grab that particular column. Now it's obviously being flattened out into a nice printable read, and also to keep in mind that it's actually still not a vector. This is now, instead of a pandas data frame, this is turned into a pandas series. Basically, a particular row has its associated indexer, as well as its associated columns by name. Again, these are things that if you don't understand pandas at the get-go, it sort of becomes more familiar as you interact with it. So you can basically select you can select rows based on their names. You can also df subjects dot iloc for index local location, sorry. And if I wanted to grab that first subject row as well, I'm going to comment this out real quick. You can specify it now by its index position. If you have it named, you can specify it by name. If you have it by index, you can specify it by index. Again, pick and choose your poison if you remember which one over the other, or you have a personal preference. You can, with iloc, now you're able to do the thing I was mentioning before. You can grab multiple rows and multiple columns. So if I wanted to grab the first row and only the IQ and IQ matrix, sorry, handedness, IQ and IQ matrix, now I can do it in my traditional row column format with a colon associated.
Do you mind if I ask?
Oh yeah,
Sorry,
please go ahead.
do you mind if I ask another? But then if you want to get information about as many columns as possible, then you surely can just use iloc and then specify a large number of them, as opposed to just using the names, right?
Yeah, you can, if that's
With
your personal preference. Because you can do similar
it's more
things
like when you
with
just
loc.
want to see like a single one or very few. What would be the advantage of .loc?
Personally, selecting like a subset of data based on like index positions, I do prefer it by number. It just is more sensible, especially if they're in sequence. But there are instances where you may want to select like certain subjects, like, I don't know, skip every 2, maybe even ones. I may want to make a string of list string and then I subset it out or something like that. There could be instances where both are useful. I'm just sort of showing you both as options.
Thank
you. Because the same thing as just like you mentioned is that load can still do also the named subsetting. So I mean, let me see if I can write this out correctly. So subjects. So if the first row should be subject 0, 0, I could actually also specify the handedness IQ matrix. You can sort of see how this maps on this worded named version maps onto the index version. And hopefully, yeah, good. You can get the same thing. You can also, because of the way syntactic sugar is spread out in Python, you can actually even use the colon, indicator as well. So it's not like you can't also do like the 0 to 10 kind of thing with a named index. You can do the same thing. Again, up to personal preference. It could be more verbose, it could be more clear for you if you think one way versus the other. Again, just showing you both ways that Python can operate. Okay. So just subsetting with pandas, flipping through my little script. Okay, moving on. All right, so let's say you want to just pull out df subjects, the age column. You would just specify it. It doesn't look any different if you specify the row index versus the column index. If you take a look of df subjects age versus df subjects like subject 001, there is no difference. I do find that sometimes a little bit confusing if you don't know what headers or row index are in your data frames. So just be a little bit mindful about that. But if you pull a column, notice that they come with their indexed variable, right? They come with the particular subject, and then you can continue to subset into it with another square brace subject 004. And right, you can keep on chaining things as well. Something to note is that, like I mentioned before, if you comment that part out, if we just have the column extracted, this is not a vector, and it's just its value. So like it comes with subject 001, it comes with subject 002 as its named component. And then the value, like the 20, that 31 of the age is actually paired together. If you only wanted the numbers, and that's basically a pandas series. If you want the values, you have to actually put dot values and it will pull out those numbers only and give you as a NumPy array. So sometimes that could mess you up if you accidentally get a named component to that. And so you want to do math on it. Pandas works well with pandas, but sometimes pandas not work well with like scikit-learn or something like that. So just be a little bit careful about what you pull out. And you can, for the most part, pull all of these things out. Just as a reminder for people who were not with me yesterday, but you can also always call dir to expose all of its hidden attributes as well as its methods. And so you can scroll and see that there's a lot actually, and the more so than the NumPy version that we saw yesterday for people who were with me. But there's also, right, oh gosh, I didn't realize there were that many. Quite a few. Right. If you don't really, and again, to get familiar with a lot of these things, if you're unfamiliar, it really just comes down to one, either reading all of that and then going to this corresponding documentation on the Pandas website and just sort of reading through. But more often than not, if you can think of a function, probably Pandas has probably written it. Okay. Below, I'm going to keep on scrolling past that. I'm actually going to run that so I stop seeing it. Excellent. Okay. And so we can also really quickly perform summarizing functions on these data frames. So df subjects, if I wanted to type mean, I could. Let's see what happens when I just type mean, even though we have both a combination of string and numerics. I run, starts yelling at me, and it's just like, oh no, why? And it's just like, you're thinking about it. My data frame contains both a lot of things. You can see it in the error here, type error. Can only concatenate string, not int, and you're like, okay, it's just a little bit mystical as to what that is, but it really is just because there's a combination of like handedness being right and left. How do I take the mean of right and left without specifying it into numerics as a combination? Well, there's also an argument called numeric only equals true. And then really quickly, we can calculate means on only the numeric values or numeric columns in Pandas data frames. All right, you can also really go like df means, assign that to be a thing, print it out all nice and neat, and use it subsequently for other calculations like that. Again, there's like means, medians, quantiles, percentiles, things that you want to do, PCA, like other things a bunch of methods out there in pandas that you can do. If everything is all organized in a table, take a look at the documentation and see what you need to be done, and it can also do it for you. And in conjunction with NumPy, if there's other NumPy associated functions that may not be provided for you through base panda, then it could be also provided for you either in other packages as well. Okay. So this sort of leads into a very easy way to make new columns. So once again, let me just print out df subjects as head, just to show you what it currently looks like, right? Subjects, some associated variables with each particular subject. Let's actually calculate, I don't know, the z-score of age. Just take any of those numeric columns and perform the z-score on it. I think I'm using age because, yeah, there's a lot of NAS inside the other ones. How do we do that? Well, column assignment is just name the column, normed, maybe just normed for shorthand. And what we can do is call on the columns themselves. So age subtracted by df subjects, age mean, right? We're doing a, first let's zero mean it just so we can see it. Right, immediately with assignment, we can create a new column. Right now it's currently 0 means, let me actually divide it by df subjects, age, dot std for standard deviation. Hopefully my parentheses are correct. And there we go. We have our age normalized into z-scores. So you can do math and assign columns really quickly as well. You can reassign over your columns, although I would prefer you not do that, mostly just to keep myself sane. We can also do another cell below. We can also create new columns with flags or booleans, df subjects. So let's say, let's find age less than 10 as a column, and just basically df subjects, age less than 10. And then print it out for me. Just print out the head. And again, right, similar ways to working with data columns. They will do it element-wise whenever possible. Cool. So now this is usual general manipulation of data frames. That probably is familiar for people both working in Python potentially, but also in other coding languages. One of the nice things as well that most people will probably do once you ingest data is that we have natural groupings for this kind of data set, right? We have, let's say, I just made an age less than 10. I can make younger people, as well as I could categorize by gender or by handedness that the subjects have reported. And so a really powerful function, powerful method to know is df subjects, call the data frame subjects dot group by, and you can specify the column that you want to group by. So let's choose gender just because. I print that. What actually happens is that now we have a data frame group by object. It can't print. Nothing's actually happened to our data frame. We've only really assigned gender to be split by whatever unique genders there are inside. And so actually to expose what happened, we actually need to, let's go df gender, assign it into a variable and use a for loop for df group in df gender. We're going to iterate over the group by. Let me just print each group with a space between. So what actually happens is that if you take a look over here, we actually have a tuple that is df group. This is the first, if you notice the first entry into the tuple is the one of the unique entries into gender. So we have male and female here. It's actually our group identifier, which is the female. And then if you see the second entry into the tuple, it is a pandas data frame with only the female subsetted. And obviously you can sort of see the printing is a little bit funky because of the wideness of it. But here's the second tuple. Here's the space that separated the second group. Here's male. And then everything's been filtered by male, by the male in the gender column. I believe there's no NAS in the gender, so that's good. It will also print that out. And so you can actually extract out the group name. When you do loop over the for loop, you can extract out one element that it's being iterated over. So you can extract out group name. Let's actually print that out now. Group name. And then you can print out the data frame associated with the group. So nice. We're outside of the tuple. Group names being printed separately. The data frame, you can now operate on it individually. So you can expose the group by operation. through a for loop if you are confused at any point in time and you're like, oh, what did I do? I grouped by gender and I want to do something on it, but I don't know what it actually is exposing. You can use a for loop to iteratively work on groups if you want to. However, Pandas doesn't need you to do that. I'm going to really quickly comment out that for loop so that when I run this whole entire spew of words does not print out at me. What we actually do is take that df gender. Let's say I do want to take the mean of, let's say, the age group, df gender. I can call on a column that I know is in the data frame. So let's do the age again, and then call mean on it. And we saw this previously before. What happened is that we calculated the age for the entire data set. If I calculate the age mean on a grouped by data set, what happens is that, right, correspondingly, you'll get the average based on that grouping. And you can also do all your calculations in various grouped up methods. Yes, I saw a hand in here.
I might have missed this, but when you do for group name on a df group, is there any way to know?
Like this line right here, just making sure.
Yeah. Is there any way to know that df gender contains two variables?
Excellent question. I'm going to actually copy and paste this. We can actually, oh wait. This is me typing backwards. df subjects, we can subset into the column gender, once again, spelling, dot unique. There is NAS. Oh, okay. I guess the group by just sort of skips the NAS. But yeah, so you can also type in unique. You can also call numpy unique too on the outside, but basically you can extract out particular variables that you have based on the tables. Other questions? Sounds great. Thank you.
And then if you actually want to only index in age, but also group by gender, how would you do this?
Excellent question. I'm going to keep using the categorical variables just so we can keep ourselves sane. So df subjects, I'm already forgetting what we have in here. Let's group by gender and let's say handedness, just go as we can. So df suppress that, df subjects dot group by it'll list gender handedness. Once again, print first off, no errors, excellent. That's usually my first check, even if I can't read it. Let's go df gender hand. We're now getting crazy here. We can also do another for loop just to see what's happening here. So let me just do df group in df gender hand, print prompt, print df group, just to see what's happening. Okay, cool. You see here, the first thing here is still that grouping index. Now it's female and left, right? Female and left-handed. And then next, and then it's going to be, right, the data frame itself subsetted by that condition. And then we also have female right. If we think about this through, skipping the NAS, there'll probably be four things, right? Female left, female right, male left, male right. And scroll. Yep, male right, scroll. Maybe there is no male left. Maybe I skipped it. There might not be any male left-handers in this data set. Shrug. But one of the things that you can do, especially with the way that Python is able to expand, is that, okay, just like before, let's give a group name so we can pull that out from the tuple. I'm going to skip printing the data frame because you sort of know what's happening there. Let's print the group name. Something I find useful is now, okay, oh, maybe there are no male left-handers. Shrug. But there's group name here, and you have female and left hand. You can also keep on subsetting. So you can go gender name, and then also hand name. Oops. And then group name no longer exists. Print and name. I think I may need to put parentheses around here to unpack all of that. I do. There you go. So if you wanted to group by more things, you can still split up that grouping variable with its two corresponding metrics into female and as well as hand. So, right. You can, this is one of the nice things about Python is that the syntactic sugar is pretty good, is that you can spread out the variable assignment, even in a for loop. I find this quite useful as well, because sometimes I may group things up together like this, but I need to do things or color a plot, let's say, we'll get to that bit later, but color a plots based on their gender or their handedness. And this will be pretty nice.
It kind of makes me think that it would have been very cool if you could just do it like methods like .. age gender dot handedness and then just get everything output this way. But I
Yep.
guess that doesn't exist. That's like wishful thinking. Would be too good to be true.
The dot spread syntax is not universal, but
No.
in Python it's a bit better to be more explicit, I think, in this way. For people who don't know if there's like a spread or compressing syntax in other coding languages. So as well with just to be complete, df gender hand. And if I wanted to do more math on age, if I do the mean for multiple things, you see as well, right? Correspondingly, the female, the gender column is all the way on the left. Handedness is a second grouping category, and then we have our corresponding numeric math calculations. Cool. Hopefully, not too bad. If I also wanted to do the means for all the numeric things, if if pandas is smart, and it quite often is, it will do that all for us. And so, right, it'll do that mean categorization on all things that it can calculate, including the Boolean. Please note that, including the Boolean column. Something to notice is that especially for people who aren't familiar with how pandas likes to print out, again, like I said, the height of these columns matter. So age, IQ matrix, that stuff, notice how it's offset by these two right here, right? That seems a little odd. You would think it's like, oh, maybe it's just a printing error. No, this is by design. These are actually the columns themselves. So like, right, age is a column, IQ is a column. Gender and handedness are indexing variables. So if I scroll back up, bear with me, subject ID was the indexing variable. In pandas, you can have as many indexing variables as you want. It can get quite complicated. So gender and handedness are both indexing variables. And so let me actually do means, assign that to be df means, print that out still. How would I actually subset into something with multiple indexing? We can still use our loc. I'm going to do it by name, so that's a bit more familiar. We can actually subset in by going female, left. And specifically, right, 2 indexing instead of just 1 indexing now. You can keep on chaining on as many as you need for how many groupings that you have. And this will be the corresponding average values that we just calculated from there. So just as a reminder, because the printing might initially seem a little odd, it's on purpose. This is a multi-index, and you can easily think like, oh, okay, maybe I have males and females, and then maybe I have individual ROIs based on groups, and then maybe a clinical condition. It can get really indexable, I guess is the way to shorthand that. Okay. Any questions so far? Yes, please. Oh, like the printing? Yeah, you can. That's like in settings, basically. There's like a pandas dot something settings or something like that, or print settings. And you can adjust that to be like, oh, 4 decimal points instead of like, I don't know, the 8 that we have here. Yeah. Sorry, just doing a quick check over my notes. I don't want to eat up too much time into the visualization because I know you guys came here for that. Okay, yeah, do all of the grapes. Last but not least is just, okay, we are working with one CSV. What if we want to just smash 2 CSVs together, right? We want to merge data frames. Let's first load up another data frame. Opening up my file browser just to show you there was indeed in data, there was also a nodes CSV. There was a corresponding second one. So in the effort of time, it's time to copy and paste, like all good coding habits encourage. Copy. And then start changing variable names. Paste. df nodes, nodes, subjects to nodes. And I think I can get rid of most of these extra columns. Index. Let's just see what happens. df nodes, get rid of all those. Okay. Let's actually make the index column equal subject ID. So last time I did it based on index position, but again, of course, naming also works as well. And then use calls just to get shorten this up a little. Subject ID, tract ID, node ID. And let's just do FA. If the abbreviations didn't give it away, this is just a CSV with tractometry metrics. So you can sort of see the track ID, left dynamic radiation, For any individual subject, we have sampled 100 points of their fractional anisotropy in the CSV. The same subjects from the subjects, which was the demographics CSV, we also have their corresponding diffusion metrics in this secondary CSV. And oftentimes we do have this kind of split naturally where we have a demographic CSV if it comes from a different survey or a different collection time point. And then of course, derivatives off of our processing pipeline that we may have also made into a CSV. So just to show what other things you'll most commonly do is you'll actually merge the two CSVs together. I'm going to print the subjects one once more at the head just to see which columns we can actually merge on. If you noticed, I made both of the indexing columns the subject ID, right? These are the unique identifiers. Each of one of these rows is associated with whichever ID is there. If we wanted to merge or combine the two, there needs to be some column, doesn't have to be the same name, but if it were, it's easier, that you have to be able to merge on or combine and concatenate width-wise. So the pandas call is basically pd.merge, and then whatever is your left data frame. So if you want to think of it as like you're going to take one data frame and smash it with the other, think of it left and right. Our left data frame is our DF nodes. Maybe because I want to repeat the demographics metrics because there's multiple values per subject in the nodes data frame. DF nodes is my left, combine it with my DF subjects. Let's just give it a quick look to see if this will work. It doesn't because you keep on scrolling down. No common columns to merge on. We actually have to specify the common columns to merge based on. And like I mentioned before, we can specify left index. So using the left, that's why I'm specifying like left data frame versus right data frame. Left being DF nodes equals true. Give that and also right index. So the subject ID in the left one, in the right one as well. Now we can merge the two. And I'm going to actually really quickly assign this to be so we can actually print just the head. Okay. And you can see now that we have subject 000. Each one of its rows from the original DF nodes now has a repeated column 4, right? This is the same exact data, that 20 male, 139, 20 male, 139 is repeated for every single row that it's able to merge on. And if you think about it the other way, if we try to do DF subjects and then merged on the left, there has to be some sort of rule that would repeat, right? There were multiple columns per subject. You just have to be careful about which way you specify is the winner. So like, right, left is a winner in this case where all of its columns are matched first, as opposed to the other way.
Can I ask another question?
Of course.
Actually, maybe 2 questions. One would be, is there a way to merge specifying that you want to exclude all nans? And also, do you want, just for the experiment, to try setting either left or right to false just to see what happens?
Yeah, for sure. So if you want to exclude NAS, I think for me personally, I would have actually just cleaned up the data frame beforehand. So let me, I see subjects has more NAS. Let's actually exclude handedness. So we can subset. Well, let me go on handedness first, just so I can show you the column. We have NAS, rights, and there's lefts in there as well. You can double check. Yeah. It's not isNan, isNa. There we go. Then there is a method called .isNa. It'll give me trues and falses for where it is. And actually, I can take this index, DF subjects, more brackets, and then call it on. And then if you take a look and run this, I'm only subsetting for NAS. And I can also, and then of course, just to get not NAS, it's to reverse it with a tilde. And now we have this state's DF subjects. If I assign it to be a variable like DF subjects, no NAS, I'll be able to do this first, and then I'll merge on my second data frame. At least that's how I would do it.
Right.
I believe there is arguments that say like drop NAS or something like that, but I tend to like to be a bit more explicit. I went through that quite quickly, sorry, and I also forgot to mention that you could subset based on Booleans. But does that part make sense for everybody? Hopefully we're okay. Okay, head nods. Excellent. And of course, you can see now, right, we have in this join data frame, we could group by subject tracks, node IDs, calculate fractional anisotropy values for everything, you can sort of see how this could quickly grow into a multi-index thing, as well as have many different utilities if you had multiple metrics as columns as well. Okay. Okay, I am on time. Deep breath. Everything okay? I'm going to transition into plotting. Okay, thumbs up. People on Zoom okay? I'm going to check my Slack real quick. Okay. Oh, would anyone have the code? Sorry, Emma, you left a message in the Slack. Would anyone have the code for loading in the data frame? How about I scroll up? Which one? Both? Okay. I unfortunately don't know if I can really quickly look. Watching my fingers type quickly. Da, 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 da. This is for the DF nodes. Sorry if it's pasted poorly. DF subjects. Where's my Slack? Here you go. Hopefully that answered your original question. All right. Good moment. Open another tab, as well as another Python notebook. Rename it just so I don't lose track of who I am. Plotting. Don't name like me. These are terrible names. Okay. So in Python, historically speaking, most of us use import matplotlib.pyplot as PLT, short plot, as our main package for plotting. Most other other packages that you might know of, including things like Plotly, as well as Seaborn, which people also are very familiar with, they're based on like pyplot basically. So if you have this as the base and then any subsequent appending packages, these will also be useful just to know the base functions, and then you can go off and be fancy elsewhere. If people are familiar with tidyverse, basically this is like base R plotting, and then Seaborn, which I'll talk about a little bit towards the end, is like tidyverse plotting, if anyone knows those things. So just also to elucidate on what this sort of syntax means, import, right, the package name, specifically the package name itself is matplotlib, and there's a dot syntax right here. This is just indicating a specific submodule of the package. Many, like NumPy, I could have been like NumPy dot, I don't even know the sub-package names, like summary statistics or something like that, and only import that particular, those particular functions and operations accessible there. Some people write their packages organized in this manner. This is, I think, a personal coding preference or organizational scheme preference. You can always load the base package itself. But if I did that, so if I did import matplotlib, as I don't know, maybe just import matplotlib, every single time I wanted to call something from pyplot, I would have to go my MATLAB really is showing today, matpyplots. And then I don't know, we had to do like a plot. I'd have to call it in multiple times. And that's why there's a lot of people who like to do the shorthand syntax where they call the submodule specifically and assign it to be a shorthanded variable. Okay, from that, make sure I have it. Now, as the name implies, historically speaking, when Python was first really getting off its grounds, I don't know if it was that early. I wasn't actually around for that era, but essentially people were like, okay, we're coming from MATLAB, if you know that language. I want to just do random plots. I just want to do like IAMShow, plot, scatter, histograms. Basically, they just ported over MATLAB like functions into Python. So like subplots, things like that. They're all going to be really, really familiar to you if you already know a little bit of MATLAB. Not so much if you know R, but hopefully we can get there. So one of the first things you want to know is that we can create a new plot by calling plot.subplots. No need for any sort of argument. And the variables out, if you notice that I'm also assigning two variables. Fig is the figure handle. Axis is the actual axis that we're plotting on. So Fig has all those things like its aspect ratio, figure size. Axis has the exact data points and how you can actually add additional plotting items to your figure. So me not calling anything gives me an empty blank plot. And just like other plotting software, it's an iterative thing, right? You plot the base canvas, and then you keep on plotting things on top of it. And we can keep on calling additional things on top. So I'm going to do a little bit of typing, and then I will post it in Slack. Thank you for the reminder person on Zoom, just as well as everyone else here. So I'm just gonna make, essentially, let's pretend we have 6 trials of something. We have a first block of some numbers. These don't have to be exact, but I have a cheat sheet that I'm working off of, and hence why these things are very particular. If you have the curriculum open, I believe it's one of the first few cells. You can also grab this from there. But while I'm typing and making a lot of typos, second block. Any questions so far? Yeah, just me making a really quick data frame. Well, data values to plots. And you can sort of see that if I had this in a data frame, that this would be easier to do. 92.7. Third block equals 50, making lists of lists. 7.8, 98.1, 98.8. Hopefully I did this right. I'll do some extra spacing just so you see what's going on. Hopefully I have 1.6 values per. Give that a run. Okay, nothing crashed on me. To Slack. That's a block. Code. For you to have it to hold and hopefully to copy. Just to have some data values for us to plot. So let's pretend we had, like, I don't know, 6 trials of a first block condition, second block, third block condition. And let's actually iteratively plot essentially a line graph. New cell. Start off with your figure, axis, plot, subplots. If I want to be very explicit, let's have subplots, one row, one column. And what we have again, similarly, if we didn't have any arguments in, this would just be one figure panel. To add things on top of it, we need to call onto axis. Axis is the actual axes that we're plotting on. Dot plots, then we can go trial and then first block. And automatically by default, we get a line. You also see that it'll automatically print matplotlibs lines.line2d. If you do not, the general rule is that Jupyter Notebooks will print the last thing. This is the output of that axis. Sometimes I suppress it by assigning a figure handle to it, right? Just assigning a data value to that last call I made. But honestly, that makes my code a little bit weirdly formatted if I don't grab an axes handle from every single line. You can just do plot.show and it'll suppress that as well. Just in case you didn't want it. I'm also going to zoom out a little so you can see the figure as we keep on going. Now you can of course mess with the aesthetics. Some important arguments probably to know is color. So let's make this black and you have your strings for your color. You can also, there's, I believe, the same colored names that are associated in R, if you are familiar, is associated here. So like your usuals, light grays, dark grays, Gainsborough, red, blacks, blues, that kind of thing. Those are all very familiar. And you can of course specify RGB values as well. Let's keep on plotting on these additional blocks of data, right? Block, color equals light gray, maybe. Just like in usual traditional plotting software, you keep on adding layers, I added that first block of data, second block of data, and you can of course add that third block of data. Third block, color equals dark gray. Just to keep it in grayscale, because I can. Hold the phone. Maybe I do want it graded. Light gray? Okay, there we go. Dark gray first, then light gray. Just make it graded for first to second to third trial. You can also give each of these a label. Label equals first block for the first line there. Correspondingly, label equals second block. Label equals third block. Name it whatever you want, whatever condition that you care about. Just because we're sort of in our fake blocked design here. If I run this, you notice nothing actually happens. Giving a label to each of these lines only will show up if you do axis.legend as well. And automatically it'll try to place it in the nicest position that it can. In our case, it's the lower right-hand corner. And of course, nothing is complete in a figure if we don't have our axes labels. Axes dot set X label, trials, axes dot set Y label equals percent correct. Run that. And of course, right, now you have your axis labels. Font size can change, font type, style, all the things that you can mess with graph programs wise, you can definitely change. You can also have a title, axis set title. And so surprise, surprise, this is actually data from, if I typed it right, from Harlow 1949. And it will pop up on the top as well here. So again, if you're familiar with any coding language or any sort of graphical interface, you have all of the options to keep on setting additional axes and labels that you wish. You also have, we're gonna try our best here to not be too muddled, but color. We also have marker, right? Instead of just having, well, sorry. Instead of just having the lines, we can have our points as well. So if I do a circle, we have our filled in circles. I'm going to keep on trying my best to show a lot of these different kinds of things that we can do. We have V's, those are for little downside triangles here in our second condition here. Enter, so I give myself a little more space. Marker equals, I think it's a top caret, be an upper triangle, yep. Right, you have all your markers, your X's, pluses, additional things. I think you can do crazy other things for plots, but these are your standard ones that are available to you. And then the last but not least, something else that you may or may not want to mess with. Now I'm on this row right here, line style equals dash dash. Yes, I enjoy typoing. Style with a T. Right, we have our dash lines. And we can, of course, do dot dash, I believe, line style. Style equals dot dash. Oh no, is that really my MATLAB? Ah, here we go. Okay, dash dot. Dash dot. Dash dot. There you go, right? We have our dash lines, dot, and of course, I'm going to show a colon one, and that should be as many things as you want to mess with. Honestly, it's too much in one graph. You notice as well, while I was changing all of those things, because I had those labels and the corresponding axes handles, these will, sorry, these will also populate in our legend as well without me having to manipulate anything. So now, all right, our first blocks are circle dash dash lines, and correspondingly we have those markers, and also as much as the legend can show the different line types. Okay, we're doing okay? Cool. Now, again, I did have data for visualizations, and that was me just typing and working off of that one particular set of numbers. You can obviously easily see that, right? This is just a list of numbers. We can just pull in our CSVs from various places and then plot them as well instead, especially with that group by function I was sort of implying as well. We can keep on plotting things on top and have a final plot show after our for loops if we want to do any sort of grouping type. But just to work with a smaller data set, I did have, I'm just going to assign it to be df pd.reads underscore CSV. We'll see if I can remember our pathing. Jovian, curriculum, Chang, is, I'll post it in Slack. Visualizations, data, visualizations, because I'm not that interesting with my names, CSV. Ah, excellent moment to import pandas. Name error, name PD is not defined, import pandas. So that was in my other notebook, SPD. Run that, run this again. Enjoy that my pathing is bad. Open my file browser, start crying. Oh, that's because I'm here somehow. I made my notebook in my data folder. I just dragged and dropped that Python notebook out into my home directory. Excellent, I can't remember where I am. Now you're enjoying me debugging, so where am I? Ah, close that. Oh, sorry, sometimes I do things too quickly and I don't explain what I'm doing. I remember mentioning that you can actually call bash commands from Jupyter Notebook. That's with the exclamation point as the first thing. PWD, just to figure out where my notebook thinks it is. Noticing that it's in the data right there. I'm gonna just exit out, save, You can also shut down your kernel. Basically, if you notice here in the Python notebooks, there's like these green dots. That means that notebook is currently running or is like active in some sort of way. So even when you close, it doesn't actually shut down. You can right click and hit shut down kernel, give it a second, that green dot will disappear. And you can see that going away, restarting. I think this is run all, fingers crossed. Restart kernel, run everything. Excellent, everything is running. Watch it crash anyways. No, I bet I spelled something wrong. Chang. Copy.
No ads.
Thank you. Why is that always the case for everything? Aha. Success. Thank you. We have basically that same data frame that I merged from previously before. This time I just subsetted it so that we didn't have too much data if we wanted to work with the plots. I'm also going to add one more thing, which is index the column equals subject, lowercase subject ID. Okay. So someone mentioned in the on the Zoom call that we can also, what do I do with NAS? Well, because plotting can get really messy with NAS, you do want to clean your data first. We can actually clean our data even more liberally by calling df.dropNAS. So any NAS or anything with a column with a NAS, it'll drop it. This will, like I said, very liberal. It'll drop everything, whatever column. As opposed to the previous way I showed before, that'll just drop, if I remember correctly, NAS with handedness. That doesn't mean if there were NAS in other columns, it would still keep those. So just dropping all the NAS just because it'll make my life in plotting a little simpler. Let's actually copy and paste this into Slack because all of my crazy pathing problems, fingers crossed.
So does matplotlib require pandas then to work? We should always import pandas first.
Matplotlib does not require pandas. Pandas was only required to read the CSV. This is just me not wanting to type out more data.
Cool.
Like if your data was in a text file, you'd have to read it a different way. If it was in like a NumPy file that I showed some people yesterday, like exporting to NumPy, you don't need pandas, right? Pandas you only need pandas really if you have like CSV or TSVs or Excels to read from. Although you can make all of those things, right, into pandas data frames by maybe making a dictionary and then calling pandas data frame on top of it, and that will make it into a data frame. Again, it's mostly for simplicity and access to panda methods if you wanted them. Excellent question. Thank you. All right, let's do DF age groups. I'm going to make a data frame where I group by, let's take a look at some of these columns. Age less than 10, maybe also tract ID, so different kinds of diffusion tracks, as well as the node IDs. So different points sampled along those tracks. DF age groups, head, just to show what's happening. FL, that's right. When we group by things, they don't actually show up, that's right. I also forgot. Let's actually now do some math on it. So again, this is mostly showing you like what potentially you would do if you wanted to work with pandas a little bit and also then make numbers that you want to plot. So if I wanted to only get the fractional anisotropy values for some of the younger participants in this particular study, I can do age groups, that's already the grouped by data set. I calculate the mean, numeric only, things that I've showed you that were previously familiar. Close that so you can see a little bit more. Younger FA.head, just to show. Once again, we are now in the multi-index land. We have both age less than 10 as a grouping index, as well as tract ID. So different kinds of diffusion tracks. So like this one, for example, is the colossum forceps major, as well as the individual data points we've sampled along. I've also averaged everything else with the numerics only, but mostly I'm interested in that fractional anisotropy value. So right in the data set, the CSV that I provided for you guys, there's multiple subjects, males and females. They could be less than 10 or more than 10. I'm just averaging their FA values on that based on that criterion. If you also notice that all of these demographic variables aren't really of interest to you, we can actually go as well a subset, loc, true. This is where the multi-indexing gets a little funny. is that if I subset by true right there, I'm only grabbing people who are going to be less than 10 true here. Just like my younger FA implies, if I do that, I'm still printing just the top. Let me print out a little bit more for you. We have different tract IDs, their nodes, and their FA values averaged up. You can sort of see how this can be really quickly chained up into a lot of different commands. I could also have done this in a for loop if I wanted to subset based on true, false, or whatever unique identifier or indexing I have in my data set. So let's actually make the corresponding older fractional anisotropy values, copy and paste, starting to just change my variable names only a little bit, otter, older. And then the only place that I think I need to change would be here for false. Instead of having just the youngers for that index on true, it'll be the older. Now, let me just double check. I print that. Yes, cool. It looks the same. Something to note, especially because I mentioned that this was a multi-index thing. If I wanted to also subset into a specific tract ID, it does fall in order for how it prints. So let me really quickly comment this so I can show you what I mean. Is that, wait, df age groups means, mean numeric only equals true. Watch me continuously spell things incorrectly. Okay. Suppress that. Is that indexing does go from left to right. When I said true, it only worked on this indexing column. If I wanted to include copy instead of typing, I will more than likely get that wrong. We do have to include that as the next indexer. So I can't put cols and forceps major first. It won't really understand what that means. Blah, 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 blah. Did I forget a parenthesis somewhere? Probably. Yes, I did. Boop. Around the indexing variables. There we go. So you can specify multiple indexes, but they do have to come in order that you index them on. So that first Boolean condition, then the tract ID or whatever you specified. And if I wanted to node specifically, that would be my third indexing into this multi-index pandas data frame. You can sort of see now why I mash the pandas and visualizations together. They sort of come hand in hand oftentimes if you are working with these kind of data sets. All right. Any questions? I'm going to retype that original, and by that I mean copy and paste the original. So I can go back to my example. But I'll keep that commented so people can look at it later if they wish to. Uncomment that, suppress that. Okay, everything's hopefully all okay again. Questions so far? Moment for myself to breathe. Okay. So like I mentioned, you can definitely do a lot of plotting on top of each other, and you can easily do that with the for loops. So let's open up another figure, axis plot.subplots, plots, 1, 1 this time again. For, I'm actually going to print older FA, just remind myself. We have multiple tracks, so let's maybe plot each of these tracks on top of each other, or plot the profiles for each one of these tracks. So for tract in df tract ID dot unique. So each unique tract from the original larger data set, we can do x plot from our younger FA, subset that by the tract, sort of like I was doing here, but this time just using it by the named value, as well as the younger. Yeah, and then also giving it a color. So let's go black for the younger, and then x.plot older FA tract color equals dark gray. I know I exited out of my for loop, plot.show, and very quickly we can have a lot of different profiles, one on top of each other. And of course, we can give these, once we're out of the for loop, x.set x label. These are actually our node IDs. Node IDs, and then x.set y label. These are our fractional anisotropy values. Okay. And these are for every single different tract. If you are familiar with diffusion data, some of these might be familiar. If you can see some of these, this is like the temporal lobe right there. I see the arcuate in here, sort of as a mess. However, because this is sort of a mess, right? We want to do multiple subplots. We can do it a few different ways. let's try to keep on subsetting down, just working with our pandas subsetting skills. We can also go fig, ax1, ax2 with the parentheses, trying to extract out different axes, plot.subplots, plots, 2, 1. So 2 rows, 1 column, 2 rows, 1 column, 1 column, 2 rows. There we go. And go ax1, plot, younger FA. And let's just pick one, left arcuate. Watch your spelling, because I'm watching my spelling. Black, x2, dot plot, older, FA, left, well, left, arcuate. And that brace color equals dark gray. Plot dot show. Yay, now we have these two plotted side by side. And of course, correspondingly for every single plot, x1 can have set x label to be node. I just wanted to show you that, right? For every single axis, you can perform any of those actions I showed you before on these ones individually. As also, you can see that these are some very squished up graphs. Okay, we also have additional arguments in here for fig size equals width-wise 12 inches maybe by 8 height. Okay, cool. Maybe I do actually want 2 columns. Okay, that looks a little bit better. It's too wide. Right, you can again, of course, mess around with these things as you wish. Okay. Standing in the same position makes my feet numb. Sorry. 1 second. Quick moment to pause, just checking Slack to make sure that no one's asked me questions there, or if I posted things. Okay, great. Questions so far? Okay. All right, in that case, last but not least, for at least the base plot functions, is that, of course, we oftentimes don't work with figures that only have 2. Like this is just very quickly an example for 2 subplots. Of course, they can get quite crazy. Let's make I believe a 5 by 4, and how we can work with that in a for loop. So fig axes, instead of unpacking each of these axes, so plot subplots 5 by 4. What happens is that if we wanted to unpack each one of these, sometimes you'll see some people do this, like 1, 1, 1, 2, ax 1, 3, and then you'll have to like keep on basically make a nested kind of thing to unpack every single axis. However, that is sort of unreasonable. Let's just actually assign this to be a axis variable. And let's show you what happens is that what happens if you have multiple subplots is it sort of gives you a matrix of axes. However, the plot will be configured is where they will be located, both row, column wise. And so if you wanted to iterate over this, you would have had to do like, okay, 4 rows, 4 columns. So that would be like a double nested for loop, which is sort of annoying. So instead of doing that, we actually have a function that will help us out. So I know 5 times 4 is 20. So for I in range 20, let me double check, print I. Okay, yeah, cool. We have just our 0 through 19. I'm going to really quickly make a track list equals df tracks ID dot unique. Quick sanity check that this is actually what I want. Just list of unique tracks. Cool. Quite a few of them. Good thing I don't want to type all those. Oh wait, sorry, that was me muting out of habit. So for 0 through 19 or 20, current track is tracks index of first thing. So now we have our track name, axes dot flat, and then index in based on the number. So it'll go 1 by 1. So if you're flattening that giant matrix of axes, let's just keep on plotting what we are familiar with. Dot plots, younger underscore FA, tracked color is black for the younger cohort, axes flat. Braces dot plots, older FA, square braces tracked color equals dark gray. Let's actually also set the title to be the track name so that I will remember where everybody is. And then axes dot flat There's another one that you may want to be familiar with, especially if you're plotting a lot of things, turn off the axes. So like no numbers along the edges, just so we have a cleaner thing to look at. We can plot dot show. Fingers crossed. Ah, track list. There we go. And now we have all the axes off. So that's what the axis off turned it off to be. It's still really squished, which is really not very nice looking. There's another argument that might be of worthwhile to you is tight underscore layout equals true. It's trying its best to make it so that everything's spread out, but honestly, the figure size is too small. Big size, let's make it big. 12 by 12. Yay, there we go. And now we have multiple axes for every single one from both our younger set versus our older set. Again, like I mentioned before, you could have done a group by instead of having to make them two separate data frames. You can imagine different loops in different ways. Okay, just to show you what happens when you don't do tight layout equals true, I believe, even with such a wide space. Wait, make it smaller. Starts to like overwrite, like you sort of see left cingulate hippocampus is like sort of smushed up next to each other. We try to make it true. I think it'll try to spread it out a little more if it has more space. Or not. I believe I made it big enough. But either way, I do recommend tight layout. It does make things a little bit cleaner. It just basically tries to maximize the space that's been given, just so you have in your subplot space or your canvas, everything hopefully not overlapping. Okay, let me scroll up. You can look at the nice pretty plots, but also you can look at the code. So in case you were typing. That's how you would mess with subplots and working with it instead of having to go row by column wise. Last few types of plots I want to show, just so we have gone over a few other types of things, is that I want to talk a little bit about Seaborn. So yesterday, people mentioned that they were familiar with R to some degree, not everybody, which is fine. Import Seaborn as SNS, that's the usual abbreviation. Seaborn is essentially the tidyverse version of plotting. If people know what that means, you'll know what I mean. Basically, you call on the columns and then the plotting package or software will figure it all out for you. Instead of having to specify, oh, along my x-axis, I want these values. Oftentimes you give the Seaborn a data frame. So the pandas and plotting are very intricately tied. Sometimes you give it a data frame and then you specify the columns that you want along each axis. And so, for example, if I wanted to make, I'm going to actually really quickly clean up my data frame, keep columns, just so we have it be a little shorter. Age, gender, handedness, and handedness, IQ matrix, IQ vocab. I'm just making a list of the columns I want to keep, and then DF subjects, back again, keep calls. DF subjects, head. Okay, great. Just making a smaller data frame without all of the tracked values so that I can plot these things a bit more quickly without Seaborn yelling at me. Seaborn, S and S. I sort of think is funny, especially how we have a lot of texting these days. We have a function called bar plot. And so previously we would have specified, oh, along X, we would have actually had to calculate how many people are left-handed versus right-handed, and maybe also their corresponding mean IQs. What Seaborn does is, like I said, it takes in data as a first argument equals DF subjects, my first data frame, DF subjects with an S. Along the X-axis, I want handedness, let's say. And notice I'm specifying the column of the data frame, Y equals, let's say, IQ. And I'm going to just go plot.show, see what happens really quickly. Aha, there we go. A real quick plot with our handedness on the left and right, and it automatically performs the average on the IQ. And you can keep on specifying additional ways to differentiate your bars. You hue for color. You can also have gender. And it'll automatically split it into, so that's right, there was no males with, females with, no, males with left-handedness. And right, it will automatically do that for you without any of the calculations that we did previously. So if we did the group by handedness and gender and then did the mean and then correspondingly plotted those means, Seaborn does a lot of this stuff automatically for you. And we can also specify, if I don't like the blue and orange, palette equals dark gray. End my string right there. And it'll change off to a grayscale version of this. And if you wanted to make this on a particular axis, you can just put, just like I was showing before, plot.subplots, subplots. Let's pretend I have 1 row, 2 columns, fig, x1, x2. So if I did that, did I do that wrong? Yes, I did. Without my parentheses, I believe there is an axes argument, x2. It'll put it wherever you specify it to be. So like in combination with regular matplotlib things, you can specify which of these Seaborn axes you want to plot on. If I had another thing on the left-hand side, I would put it there. Let's actually do that in a second. You can also, again, specify, right, fig size equals something much larger than this. There we go, right. Oh gosh, too tall. 4. Yeah. Right, again, anything that anything that matplotlib can do, Seaborn can also do. Because Seaborn was made on top of matplotlib, any sort of associated matplotlib functions will also still work. Just some other kinds of plots that might be useful for you to know. Go down right here. Is, okay, fig axes, again, x1, x1. Oh my gosh, with my parentheses, x2 equals plot dot subplots, 1 row, 2 columns. Is we also have things called swarm plots. And then I'll give you those arguments in a second. We also have things called violin plots that you might be interested in being able to do. And also I will give you the arguments in a second. Because I'm going to be plotting the same data, something that's more Pythonic is that we also have keyworded arguments. This is not really just plotting, this is more just flat out Python specific, is that instead of having to specify the same arguments in every single time, I can specify arguments based on their name. So df subjects for data. You can sort of see previously before, right? I typed it out 1 by 1. I could have copy and pasted this and put it into our next plots, but let's be a bit more succinct about it. X can have handedness. Y can be IQ again. Let's keep that, keep it that way, and we'll keep it black and white just for simplicity. That dark dark gray. And this is just a dictionary. I've named it keyword args. I can also just name it plotting keyword args. You'll probably see this oftentimes in Python, especially if you read documentation. Kwargs is short for keyworded arguments. And I'm just basically giving a field that is the original name and then the actual values I want it to be. And what we can do with this is we can do a spreading syntax, is that we can actually do asterisk keyword args. And that'll basically put all of those arguments into my function without having to specifying them over and over again. So if we have shared things, we can do it this way. So because I'm also going to be plotting the same data, keyword args here, plot.show. Fingers crossed, it works. Probably not. Swarm plot, not plots. Kwargs, because I changed it to plot kwargs. Passing palette without assigning a hue. Fine. I will give you a hue. Hue, what? Hue equals handedness. My bad. Axis equals x1. X equals x2. Now I'm cooking live. I'm not so sure this is working. Interesting. Oh, it's still running. My bad. While we wait for this to show, hopefully, that it will show. Fingers crossed. Any questions so far? I'm now really scared that there's too much data in DF subjects. Casually. Good moment to show you what happens if your thing is hung. You can stop right here. There's a stop button. It'll still take a moment to stop itself as well. Please stop. Okay. The reason I know why it stopped is that the asterisk stopped existing. Let me go DF subjects real quick. Oh, that's why. There's 100,000 rows. Let's not do that. Let's not do that. DF subjects. Let's go only the, I don't know. How do I make this smaller? DF subjects dot. Oh, I see what's happening. Unique. Data has no value. Unique. That's right. Subjects. DF subjects. I can see that all the data is being repeated. If you also saw that, dot head. Subject 7 is repeated multiple times. I had forgotten to actually make that smaller. Elsewise, this data set is hilariously huge. DF subjects. How do we do this? DF subjects. Let's actually only do. Oh gosh. 1 second. While I'm currently trying to debug my own example, do we have any questions so far about what's going on? That's right. DF subjects, drop duplicates. There we go. Subjects. Try that again. Violin plots. Oh, there we go. Sorry about that. Although watching me debug hopefully is a little bit fun. But essentially, you have also different kinds of plots that Seaborn is able to do for you without having to specify anything else other than the arguments you want. Yes. Nothing.
Oh.
It drops duplicates based on the row information in it. I just reassigned DF subjects to be DF subjects. All right. The power of Seaborn is really the fact that they provide for you automatic plots in different types, like box plots, whisker plots, violin swarm plots like this, violin plots like that. Specify the color as you wish. The only thing that's the downside is that you can see the power of it, right? I don't have to do much calculation in order to get these things to occur. The unfortunate bit is that customizing on top of it is a little bit harder because it's already pre-made for you. It has a lot of custom aesthetics. Preset aesthetics that can't really be easily messed with without having to dig into it. And that's sort of why I showed you matplotlib underneath. Anything Seaborn does, you can adjust with matplotlib because of its the dependency that it's based on each other. Feel free to, by the way, my cat tabs in case people wanted that. Matplotlib, documentation that you should become very familiar with. They have a lot of tutorials. So if you have any type of graph that you wish to make that has a tutorial, honestly, when I was first learning, I just basically opened up a tutorial and tried to adjust it as I see fit for my data. The same thing is true for Seaborn documentation. Seaborn has, I think, a better gallery. Honestly, I just peep through the gallery and see the different kinds of things you can do with it. And like I said, a lot of these figures, if you read enough papers, you'll notice that some of these figures are eerily familiar with some of our articles that we read. So we have like density curves, 2D density curves, things like this, ridge plots. Oh gosh. 2D density curves. These are things that are pre-made for you in Seaborn that are, and it's quite powerful, like I said. But if your data doesn't exactly match this kind of format or this kind of plotting that you want to do, then you would have to adjust it with matplotlib on top. Again, so a lot of these tutorials show you the basics. They also show you, I often find myself on this page trying to find nice palettes. So these are all the palettes that are available to you as well in matplotlib. I believe every single software, every single programming language has its own. Here's my palette hues. Pick and choose your poison. They're all named. And then anything else that was of interest that might be good references for people who are beginners. You can plot text, but I don't know why they want to do it this way. No, probably just this. Again, take a look at these galleries. Anything that you guys do during your hackathon, I see a lot of correlation plots or heat maps. You can see how it's really nice. It's not the full correlation matrix, it's just a lower triangle, things like this. If you want to replicate it, they also have sample code, as well as examples and as well as the tutorials I showed you here today. Otherwise, we have 4 minutes to time, so any questions? Yes,
Is there any sense in field whether Python is more hard?
these are really the big guys. I feel like Python's been playing catch up with R, especially in tidyverse. So if like you're familiar with tidyverse, like when I first joined Ariel's lab, he was like, let's make a visualization for these track profiles. And I like whipped out R and I was like, ah, yeah, we're done. And then I spent like a good week trying to figure out how to do it in Python. Again, pick and choose your tools. Tidyverse is really strong, but it's not part of this curriculum. But I will say it's a bit more universal because tidyverse is not as penetrable, I think. Yes, any other questions, both online or in person? So if people do want to work with R, by the way, definitely can. I'm also pretty good with it as well. So anything you saw here, I could probably also replicate in R if you need any assistance with that. Yes, please.
Is it considered to point to like the local drive?
You mean just this particular instance, or do you mean Jupyter in general? Yeah, if you have it installed on your local computer, yes, it can. Double checking Slack. No one's asking questions on Slack. Cool. In that case, gift of time. Feel free to go to lunch a little bit early. Otherwise, I'll be here.